Okay, I think it's time to jump in. Good morning, good afternoon, good evening, everyone. Welcome to the YugabyteDB Friday Tech Talks series for engineers, by engineers. And it's my pleasure. I'm Kannan, and it's my pleasure to welcome today for our main speaker, Denis Magda from sunny Florida. So Denis, why don't you start by introducing yourself, and then you can jump right into the topic for today's talk.
Yeah, absolutely, with pleasure. Thanks, Kannan, and hello, everyone. Thanks for joining us this Friday. Happy Friday, by the way. Enjoy your coming weekend. So my name is Denis Magda. Right now, I'm the head of developer relations at Yugabyte. So what I actually do, my primary focus is the application developers, folks who build geo-distributed and cloud-native applications using YugabyteDB as one of the components. And today we are going to discover one of the crucial topics, table partitioning in YugabyteDB. So let's move forward. The agenda is extremely straightforward. We first need to understand what's the relation and difference between partitioning and sharding, because like those terms exist and sometimes there is a lot of confusion, which term applies where. After that, we will discover and talk about types of table partitioning in YugabyteDB. And finally, we need to review and check so-called essential/advanced capabilities such as partition pruning and partition maintenance that you also need to be aware of. So moving straight forward, let's figure out what's the difference and the relation between partitioning and sharding. So first thing first, sharding. So the sharding is a mechanism that lets you to distribute your data across a cluster of servers that represent your distributed system. And in return, once you distribute your data across your cluster, you can load balance your requests, and that's how you can take advantage of much better capacity and much more CPUs that your cluster possesses. But that's actually what the sharding is, right? But what you do as an application developer, you use your basic DDL commands such as create table, or you use any other API that is provided by a NoSQL database. You create your table, and after that, this table gets split into smaller parts called shards. And this process usually happens automatically. As an application developer, you don't mess up with the sharding, at least directly, and this feature is internal to your distributed system. However, as an application developer, you are responsible for your primary keys, because depending on what you selected as your primary key, that will influence your sharding approach, because there are several sharding approaches that exist. If to give you a reference, what's supported in Yugabyte, in YugabyteDB we support hash sharding and range sharding. And then based on what your primary key is, the distribution can vary. So that's the only thing you have to care about as an application developer. The rest is automatic. So we are not going to talk about the sharding today. For that, just watch on demand one of our past Friday Tech Talk that was dedicated right for this topic. But also, if to give you a visual example, right, how sharding is implemented and works in YugabyteDB. So let's imagine that we are building an application for some pizza shop. So today is Friday, right? And like many of us are going to order pizza or burgers from our favorite locations. And we have this primary top-level pizza orders table that right now comes just with two columns, the ID and the status column. When it comes to the statuses, we have the statuses that signify that the pizza is still in progress, it's ordered or it's being baked. Then once the pizza is ready, it's going to be delivered. And the final, most tasteful status is yummy, yummy in my tummy, meaning that the pizza is already delivered to your door and hopefully you will consume it really quick. And when you are talking about the sharding, when we need to shard this pizza orders table across your cluster, it basically gets split into the shards. In this case, we have 3 shards, and also in YugabyteDB, we use tablets as the term, it's synonym. And then those records, those orders get distributed evenly across your shards, and every shard can be located in a separate and a dedicated cluster node. Okay, and this is an example of the sharding of the hash sharding, and we use ID as the primary key. And also, if you come with a background from Cassandra, Apache Ignite, or single store, then this is actually the same how it works in those databases, but they name it partitioning and not sharding, right? We name this sharding because that's actually what happens with your data. Then what's the difference when it comes to the partitioning? Partitioning is a declarative way of splitting a large table into more manageable independent tables. And this feature is commonly available in single node and distributed databases. It's available in Postgres, MySQL, Oracle, and YugabyteDB as well. So, and here is again, if we are talking about let's what you are responsible for as an application developer, like how do you work with partitioning? So here is you have much more flexibility. You still use DDL statements to create tables and to create individual partitions, and you will see how it works in practice shortly. And then you can manage your partitions separately from their other partitions that you created for the same table. You can drop a partition, you can add a new partition in runtime, you can update, let's say, your partitioning key, and the data can be moved automatically from one partition to another. So we'll explore that, but that's actually what partitioning does. And again, if to go back to the visuals, let's take the same example, our pizza orders table. But right now, you as an application developer decided to split it into three different, you want to split your data into three distinct categories. You want to store together all the orders that are being cooked or like being ordered, and you put them in the partition named orders in progress. Look at the top table. Next, all of the pizzas that are baked and being delivered, they will go to the next partition called orders in delivery. And finally, once the pizza is consumed, it's going to be added to the orders completed table. So usually you can use this perfectly well for your applications because, for instance, your customer-facing microservices can primarily request all of the pizzas that are being cooked or being delivered, but orders that are completed might be interested for more analytical workloads, and you don't want to query all of the data. You just want to query specific partitions. So this is what partitioning does, and this is actually how this partitioning is implemented, at least in Postgres, and it's fully supported similarly in YugabyteDB. But right now, if to show you a full picture, how both partitioning and sharding coexist in YugabyteDB, because we use both concepts. Okay, let's look from left to right. Again, we're starting with this top level original table pizza orders. First, if to take the same example with the distribution based on the status, we partition this table, we split it into three independent tables: orders in progress, delivery, and completed. And finally, all these tables, all these partitions are like, they're still tables, right? They're the same table. They you will be able to run the same DDL, DML commands across those tables, and you need to shard those tables across your cluster. And in this example, for instance, YugabyteDB takes your orders in progress table and gets it sharded across your cluster, across the, currently we support, like, let's say, 3 shards, right, in this example. And the sharding happens by order ID. So here is we are using the hash sharding. And again, all the shards, as it was said previously, can be located in individual cluster nodes. So that's how both concepts coexist and used in YugabyteDB. And hopefully right now you understand the difference and relation between both partitioning and sharding much better.
Yeah, I think I mean, I really like the picture, Denis, in the previous slide. And the other point it makes clear is just like pizza orders is like your logical big main table. And then in the middle section, orders in progress, orders in delivery, these are actually names that end users pick for their partitions, the children tables, if you will, right? And these are objects in your Postgres or your YugabyteDB that you can interact directly at the DDL level or DML level. Whereas when you come to the rightmost, it's all automatic, it's internal, like the shards and tablets just have internal numbering or IDs. And it's transparent because each of the tables in the middle section themselves can get very large and may need distribution.
Correct. Yep. Excellent points. And now let's talk about the types of table partitioning in YugabyteDB. So here is, again, I will quickly walk you through the primary types, like all the types that are supported. And then I'd like us to explore them in practice, because I want you to see, to witness how you use, let's say, hash, list, or any other type of sharding. So let's start from the first one, hash sharding. So this one is the basic one. It's basically when you have your primary table, your original table, and you want to partition it by specifying a modulus and a remainder for each partition. That's just a standard division operation, and depending on the result of your division, your record will go to one partition or to the other. And also you see like the third Postgres and YugabyteDB columns. It means that all of those partitions, all of those types of partitioning are supported in Postgres, except for the geo partition. And those hash, list, and range multi-level partitioning also was inherited by YugabyteDB because we are based on the PostgreSQL source code. Returning to the types like list partitioning, this one is more interesting. That's what we've already talked about by using that pizza orders and statuses approach. That's when you define a list of different values, and and based on the value that appears and provided in your row that you insert, the row will either go to one partition or another. The range partitioning is an excellent choice for when you want to define one or more keys, and those keys are numeric keys or daytime values, and you can create different ranges. For instance, you want to store all the values from 1 to 100 in one partition, and all the values from 100 to 500 in a different partition, or those can be time-bound, different ranges. Again, we will see this, how it works with our pizza orders example. Multi-level partitioning is a nice and interesting feature. It gives you an ability to come up with some sophisticated partitioning schemes. Let's say that first you have your pizza orders and you partition it by status. And in the result, you have those three partition tables. And then you can partition each, and you can continue this partitioning by taking, let's say, orders that are completed, and you can partition that one by range, let's say, because you want, let's say, you want to keep all the orders that were completed this month in one partition, but the remaining orders you want to complete in the other partition. So it's all possible. So geo partitioning is unique to YugabyteDB. So this partitioning scheme, actually, when it comes to the partitioning scheme, again, you have your primary table and you can first partition it using any of the methods above. But then what you do, like you can pin these partitions to the desired geographic location. So we are not going to talk about geo partitioning in this session. This topic deserves a dedicated Yugabyte Friday Tech Talks. So just watch, subscribe to our LinkedIn channel, and you'll be notified when this session gets scheduled. Okay, so now let's get to practice, and let's start, let's say, exploring these partitioning types with the hash partition. So what I've prepared for you, I have a simple script, and here is I'm already connected to my YugabyteDB instance. It's a local cluster, 3-node cluster that is running in Docker on my laptop. So there is no any data yet. Let's do this. Let's partition by hash. Let's see how it works. So what I'm going to do, I'm going to create this famous pizza orders table. In addition to the status and order ID column, I'm going to add order time. So we want to play with the time values. And then we are creating two partitions. The first one, orders partition 1, will keep all the records that are divided by 2 and have the remainder equal to 0. And the others with their modulus 2 and the remainder 1 will go to this partition. So let me create this table, and I will show you what's inside of this file, because we need to load the data. As for the data set, it's massive, like it's tiny, right? I prepared just a few 8 records so that we can see visually on the screen what happens. We don't need to have thousands of records for basic exercises. It's done. So the table is created, and similarly the partitions. Let's run this command first. It shows us all the relations with details. So that's our pizza orders, and we hash by order ID. We partition by order ID, sorry. And then these are my partition tables, partitions that are attached to this primary table. And interestingly, if you have never used partitioning before, so now if you want to query records, you can always query these partitions separately, because if I run this command right now, you'll see that these are tables, like those are regular tables. It's the only difference in that these tables belong to this top level one, which gives me an ability to run a query of this kind when I am querying all the data from my primary top level table. And also in this request, I will return all the columns, and I want to see where each row comes from, what partition a row belongs to. So let's see how our partitioning, how the hash partitioning distributed our records. So you can see that these two orders, they were moved to partition number 1, and the remaining orders were placed in the second partition. All right, so that's the partitioning by hash. Probably when it comes to YugabyteDB, just my personal opinion.
And maybe it might be worth showing that orders underscore part 1 is a table in itself, and we can just directly select from it.
Absolutely. Select from orders part 1. And you can see the same records, right? So it works.
So for some reason, the hash distribution was, in this small case, was a little bit non-uniform, that 6 of the records ended up in part 2 and only 2 in the other one.
Yeah, kind of. That's actually was my thinking, because originally when I was looking into this method, my thinking was that Postgres and YugabyteDB, they actually calculate the hash code from my order ID. And in this case, yeah, like I was looking, why the heck the distribution is so uneven? But in fact, they use some different approach to calculate the hash. They don't use this exact value of your primary key, right?
They first run it through a hash calculation, and then they do the modulus. So with a small data set, it's just, I mean, I think if we insert like 1,000 rows, it'll be better.
Yeah, let's look at the list, right? Let's see how the data, how we can partition our pizza orders table by list. So the same table, the only difference is that right now we partition by list, and order status is going to be used at the partitioning column. And we will create 3 partitions this time. The first one is we'll keep all the orders that are in progress. Second one is for the orders that are on the road to your house. And finally, the order is at your door, and go ahead and eat your pizza. So let's drop the table. Let's reload the data set. And then we will run the same commands to see how the distribution of our records look like right now. So on my just as a remark, on my macOS machine that uses Apple CPU, it takes more time, you know, just to drop and to recreate the schema. So it should be much better on your side. Okay, so let's see what I have here. Again, the same table. Let's see the details for this pizza orders table. So right now it's said that everything is partitioned by list, and these are my partitions. If you execute this command, then again, all these partitions are just regular tables. You can query them directly. And if you run the same query when we want to read back all the records from our primary table, let's see where each record is located. So for instance, these are the completed, right? Yummy, yummy, and my tummy. All of them are located in their orders completed partition. We have only one record, that is pizza that has been delivered. That's why one record here. And these are the pizzas that are in progress, and they are located in the orders in progress partition table. So
one question, Denis, let's say I insert a row where the order status is not one of the things mentioned in the list. Do we get an error, or does it end up in the main table?
So I think that in this case, we will get an error. So let's do this.
That presumably matches the Postgres semantics as well.
Yeah, it's
yeah. Why don't we give it a try? Yeah,
absolutely. So let's do this. Let's do this then. yummy. And let's do this, like something like this. Yeah, it's in enum even, but
so it insists that the data inserted.
Yeah, so I'm using enum type, which means that all of the data gets validated before you do this. But if you can,
well, instead of enum, if it was a text, it might have been.
Yeah, or if you can, you can drop.
That's okay. I mean, I was just curious, but presumably because we inherit the Postgres code, the semantics are similar. I was just curious. But can we? There's also a question from the audience. So maybe we go to that now. Like, question was, how are partitions different than materialized views?
Materialized views, you usually create those to keep results of some queries, right? For instance, you run a query, and that query might be heavyweight, meaning that it takes a lot of compute power or needs to kind of scan a lot of the data, but you do it regularly, and that's why you keep kind of some data hot or cold in that materialized view. Partitions are different. Partitions are for the cases. We will talk about the partition pruning next, and you will understand the use case better. But it's partitioning in Postgres or YugabyteDB, you can chunk your data, for instance, based on the status. Because as I was saying, let's say when it comes to the orders that are being baked or delivered, those orders are going to be queried a lot by the customers, because I'm ordering right now, I'm going to your website, I'm ordering this pizza, then I'm just checking when the heck it's going to be delivered. And those are different types of queries, like front customer facing queries. And you don't want, like when you run these queries, you don't want your application to query this data, right? Like, why do you need this data? And to skip, but at the same time, once the data, once your pizza is eaten, you kind of put it in a different partition, and you can have some analysts and business and salespeople who want to see like different patterns, and they will be querying this data directly. They will not be touching the different data. It's, just much better management of your resources of your Postgres, of your database.
Correct, and I can add some color also, but I'll save it towards the end. So why don't, let's go through your.
And so here is the final quick example, folks. Also, when it comes to the records, a record can move from one partition to another automatically as well. So let's assume that we have this record with ID number 6 right now, and just to confirm this record, this pizza is still being baked. But let's say that it's baked and it's ready, and a driver from DoorDash picks it up. So which means that in our system, we update the status for this pizza to delivery. And now let's see what happens with this record. If you execute the same query, you will see that right now this record was moved automatically to this partition. Before it wasn't this one. So you change the status just on your application level, and then the database manages everything for you. So here is you making this the responsibility of your database to decide where the data needs to be located and when you need to move it from one partition to another. That's brilliant, right? You don't need to complicate your architecture at the middleware level or application level. Your database does this for you. So partition pruning. Let's quickly return to the slides. That's actually, I have two last slides left, and then we will return back to the samples. Partition pruning and constraint exclusion. So when you partition your table like pizza orders into multiple partitions, then you help your optimizer, you help your SQL engine to query only that data that is necessary for your query. So generally, when you run a request, your SQL engine can decide, do I need to query all of the partitions that belong to this table or just only one or two? Partition pruning actually uses the table's partition bounds that you defined. In our last example, those bounds were the different values of your status. So for instance, if in your query, you're saying that I want to get all of the pizzas that were consumed, like the status is equal to yummy in my time, and then we suppose that our SQL engine will query only the partition with completed orders. It's not going to touch the partition that keeps orders of the pizzas that are being baked. And actually, when it comes to partition pruning, all these optimization techniques can be executed at the planning or execution phase. Constraint exclusion that we are not reviewing in this session, it's a similar session. It's quite similar optimization technique, but it uses that check clause when you create a table and you define a column. Let's say you can say that check that the value for this integer value is not like within some boundaries. And again, this also can be applied during the planning phase. However, one very important remark here, whenever this the partition pruning and constraint exclusion optimization works only if you provide constants or you provide like third-party supplied arguments. If you try to execute different functions, and it will be hard for the planner to decide what partitions to prune, what partitions to exclude from the execution, then actually for the planner, it's easier and faster just to run your query across all of the partitions. Okay, so and here we have two flags. So by default, when it comes to Postgres and YugabyteDB, partition pruning is enabled by default, and we will see what happens when you disable this feature. And final like theoretical knowledge, and then we are getting back to the to our terminal window. Partition maintenance. It basically, here is we are answering the question of what can you do with your partition tables? And the short answer is that you can drop them, you can add new partitions, you can detach partitions from your primary table and then query them separately. You can attach your new partitions. And it's better to see how this maintenance, partition maintenance works in practice and what it gives to you by looking at one of the examples. Okay. So let's do this, partition pruning. I still have this table where the data is partitioned by the status. So now let's run this query. I want to get all of those records that were consumed. Yummy in my tummy needs to be the status. If I run this query, you'll see that we scanned the planner, the SQL engine scanned only this partition. So we did not scan the remaining data. However, let's suppose that what would be the execution plan if we would have this feature disabled. So let's disable partition pruning and let's execute the same query again. You see, this is what happens. So when this feature is off, then YugabyteDB and PostgreSQL, they will scan and they will query all of the partitions that belong to this top level one. So let's do this. I want to turn this feature back because we are not finished. And finally, you remember I mentioned that this feature here is I'm supplying a constant value. And it's easy for the planner to decide like what partition to query. But let's say that I decided just to experiment, and here is I'm running quite similar query, but I'm executing two functions. First I convert this column to the text value. It's a number default. And then I'm just executing this lower string function. What happens right now? Again, the planner decides that the fast and the easiest way is just to scan all of the partitions. And finally, we have a few minutes left, but let's see how far we can go. Range partition, and by using range partition, I want to show you quickly what can you do with the partition maintenance. So here is we are going to recreate. Let me run the script first, and I will explain you what's here. We are creating the same table, but right now this time we decided to partition by range, and we selected order time is our range key. And next time creating three partitions. The first partition will keep orders for June, for this year, June. It's like for the current month. Also, I keep the orders for the previous month. Probably that's just something that is requested by the business people at my company. And also kind of answering your, let's say, previous question, what happens if your record doesn't fit in any of the partitions? Either you will get an exception or you can create a default partition, meaning that all of the remaining data that doesn't fit here will go into this partition.
Wonderful. Yeah.
So, okay, let's run this query. Again, the same table. And right now, these are our partitions. And if you execute this request, let's see. So orders others. It means that this record, that's the order from the past year, 2021. That's why you don't see it in these two partitions. These are the orders for May, for the previous month. And the remaining orders are for the current month. Everything is done magically. All you need to do as a application developer, just create your partitions properly. But let's say that the June is over and we are heading to July. Probably July is already behind the corner, and you need to get ready because your application, the purpose of these partitions is to keep, let's say, for the current, all the latest orders in one of the partitions and remaining orders in the different. And right now you have to create a partition for July. So what do you do? And also you want to, let's say you want to drop the previous past partition, like for May. So first, probably if you want to keep the data for the orders from May, you can just detach this partition from your primary table. So you do this. And when you query this table, again, you no longer see the orders for May, right? But this table still exists. If it's not gone, you did not lose any data. If you query it, you will find that the records are here. And let's say that for the business purposes, you still want to keep this data, and this data is going to be used by your analysts, like the guys who do some business intelligence. And you just want, let's say, I want to reinsert this data back. Probably that's not the best practice how to do that. But what I do, I'm inserting into the pizza orders the same records from this partition that is already detached. Let's do this. And if you run the same query again, you will see these records, right, for May. These are my records for May, but right now they are located in the other partition. So you can—
because this May partition is detached. Makes sense, yeah.
Yep. And then if you want, you can always drop this table.
Mm-hmm.
And finally, how do you attach? Let's say that you are preparing for July. That's going to be your next, my current month partition. What you do, you create this partition using create table command, and you're saying that I'm going to keep all of the orders that fall into this range. Okay. So it's, let me see. It's created. It's orders. It's here for July. And if just to do, some tests, if you insert this data, this data will appear in your partition for the July. So that's the others. We have something from 2021. That's from the May that we detached and removed. And here is the partition for the next month. And we already have some data there. So that's the range partition in practice. And that's how you can take advantage of partition maintenance. So hopefully many of you right now have an ideas how you can improve and simplify your application architectures, but relying on this capability of the database. That's extremely, I think, valuable for different IoT use cases that range not only IoT, but also like from, let's say, retail, high tech and everywhere. We are dealing with the data in motion, right? And sometimes there's so much data that partitioning at the database level gives you a lot of, let's say, choices and simplifies your upper level architecture. So to summarize, you will get this script and you will be able to experiment with multi-level partitioning on your own. Everything is here. You will find references under the resources. And also how else you can study, read the documentation prepared by the Postgres community. It's beautiful and gives you a lot of the details, high level and low level. And also YugabyteDB, you will find a lot of similarities because we are just distributed Postgres, but also you can see what's unique to us, such as a geo-partitioning. And also check this blog by Frank Pachot, our colleague, who explains again what's the difference in the relation between sharding and partitioning in Yugabyte. Or you can watch a recording of our past Friday Tech Talk on the topic of sharding. All right, thanks a lot, and happy to answer on your question here if the time allows. Probably not, or on Slack. You can always find me and my colleagues on our Slack community.
Yeah, thanks a lot, Denis. I think some really cool uses of partitioning. Just to summarize, one is just the simplification of management. being easily able to retire older data, like suppose you have monthly partitions and you want to, some databases have a TTL feature, whereas here the alternative approach could be like create monthly partitions. Maybe you want to keep 2 years worth of data, you have 24 partitions. And then when a new month rolls around, drop the old partition. It's as simple as that. And it's much easier than doing a whole bunch of DML to bulk delete a bunch of rows. I think the question of materialized views versus partitions, you already answered it, but maybe if I were to take another minute or so, just materialized views is sort of complementary, and you have a base table, you want to have a certain aggregated or summarized version of it. Materialized views creates a persistent version of it that makes subsequent querying from it much faster. Whereas partitioning is a way of organizing unrelated data in kind of separate child tables. It helps improve your scan performance. Suppose you only wanted to do some query on tables, on pizza rows that are in delivered state. You can have a much faster scan, since that's logically separate piece of information. Otherwise, you would have to create an index, and there's still more indexing overheads. So, kind of complementary techniques. But thank you so much for joining, Denis. Thanks a lot for an excellent Friday Tech Talk. And see you all next week, same time. Until then, have a great time.
Thanks a lot. Bye-bye.
Bye. Thank you.